Hello and welcome to our lesson on Radicals Explained Part 2. Okay, just to review from Part 1, the radical is actually an expression which means you do not have an equal sign. It includes a number, also can have a variable, a radical, it's sometimes called a root sign, and an index. Take a look. There's your radicand, there's your radical sign, and there's that teeny tiny number, which is an index. Now, first thing you're going to do when you have to figure these out, look at your radicand. That's the number that you're trying to break down by prime factorization. Remember, prime numbers are numbers that can only be divided by themselves and 1. So we're going to take 96, and you can break it down however you want to. I know that 3 goes into 96 32 times. And this number 3 right here is a prime number. So I put a little dot under it so I can keep track of all my prime numbers. 32 can get broken down into 8 and 4. I don't have any prime numbers yet, so I got to keep going. 4 can be broken down into 2 and 2. And oh, look, 2 is a prime number, so you have 2 more prime numbers. 8's not prime, so I still have to keep going. I have 4 times 2, oh, prime number. And then 4 can be broken down into 2 and 2. All right, now I'm down to prime numbers. So I've got 3, I've got 2, I've got another 2, another 2, another 2, and yet one more 2. So I've got 5 2's and a 3. Now, since the index is 3, this teeny tiny number here, you need to circle the prime numbers that appear in groups of 3. So they want you to go back and find 3 groups of 2, 3 groups of 3, whatever you can do. We have a group of 3 2's. We only have 2 2's, so we can't make a group out of them. And you only have 1 3, so you can't make a group out of those either. So we only have 1 group of 2's. The index is 3, so that means you have to circle all the similar prime numbers in groups of 3, which we did. We took a look at this and we said, oh look, there's a group of 3. There weren't any more groups of 3 though. That was all we could do. The leftover numbers that can't be put into the groups have to go back under the radical sign. And then those ones get multiplied all together to create one brand new number. So we are going to look at these guys right here. They weren't grouped together, and the directions said to multiply all these guys together, and they get put back under the radical sign. So we've got a group of 2's. If you have a group, you only write the number once. And we had an index of 3. And then we have all these leftover guys right here, so we have to multiply them together. So 3 times 2 times 2. So that's 6 times 2 is 12. So it should look like that. Now, when we are going to go back and double check, you multiply any of the numbers or variables that were outside the radical sign, the number of times that the index indicates. And I'm going to show you how to do that in just a sec. Then you're going to multiply that number for step 1. You're going to multiply it by any numbers that were inside the radical. And then you're going to make sure that the answer matches the original radicand that we started with. So let's take a look. Okay, we start with our whole number is 2. Multiply your whole number 2 the number of times in the index. Remember the index is that teeny tiny number? So it says multiply 2 3 times in a row. So you're going to take 2 times 2 is 4 times 2 is 8. Now you have to multiply that answer, that number 8, times 12. And we are hoping that it's going to equal 96. And why is it so important that it equals 96? Well, if we go back and we look at our original radicand, there's the number 96. When we did our double check, we matched our original radicand, which means our answer that we had written of 2 cube root 12 is correct. It did, it matched. Okay, why do we have to work with them and where are we going to see these things? You're going to deal with radicands everywhere in Algebra 1, Geometry, and Algebra 2, and even upper level classes like pre-calc and calculus. So just to name a few, you're going to see them worked out in quadratics, in the rational root theorem, in factoring, and the quicker you know these, the faster you can work them correctly, the better off you're going to be in the upper math classes, and pretty much in any math class in high school. It'll be a lot less painful for you. Now, as a quick review, Remember, the radical expression has three parts. The index, which is that teeny tiny number. The radicand, which is the number that goes under the third part, which is the radical symbol. The radicand is the number that you need to break down by prime factorization. Remember, that's the 96 that we took, and we did a factor tree with it. The index is the grouping of numbers from the prime factorization calculation. In other words, that index of 3, that teeny tiny number, said take all those primes that we made from 96 and circle out groups of 3 and take them out of the radicand sign, the radical sign. Any leftover numbers that can't be grouped together get multiplied together, so that 2 times 2 times 3, they weren't groups of 3, so we had to multiply them all together, created the number 12, and then we put them right back under the radical sign, and they became our brand new radicand. And that's it for our lesson on Radicals Explained, Part 2.